Well, Mr. Trutna here. We're going over Worksheet 3B. This is Unit 11. This is Math 2. We're going over using complex numbers, and as you can see by the instructions, it says solve the following equations for x. Express your answers as complex, which means imaginary numbers, in simplified radical form. So we already did number 2. There was the answer. It was x equals plus or minus I square root of 6 minus 3. We already did number 4 in class. It was x equals plus or minus 2I square root of 2 minus 4. We did number 6. Number 6 was x equals plus or minus 3 square root of 2 plus 5. So let's go ahead and do number 8. Number 8 was the last assigned problem on the front page. And then we'll flip it over and we'll do the problems that I assigned you on the back page. Okay, so we're solving for x in this problem. So remember, we're going to use the concept known as completing the square. So I'm going to start off with the parentheses. I'm going to put the x squared and the plus 14x inside a parentheses. I'm going to leave a little bit of a space here, and then I'm going to close the parentheses out. And then typically there's a third value over here. Like if you looked at number 6, we have x squared minus 10x, then we have a third value plus 7. However, in this problem, number 8, there is no third value to put on the outside of the parentheses, so I'm just going to put equals negative 73. Okay, so there's nothing to put there. So now I'm going to take this parentheses and I'm going to turn it into a perfect square trinomial. So how do I do that? Well, I take the middle number, 14, positive 14, I take half of it, so that would be 7, and then I multiply 7 times 7. And whatever that equals, which by the way is positive 49, you're going to put that inside the parentheses to make your perfect square trinomial. Now, since I put a plus 49 inside the parentheses, I have to put a minus 49 outside the parentheses. Now, the reason why I do that is because that plus 49 and that minus 49 would actually just be 0. And if those weren't there, those 49s were just 0, I would actually have what I started with in the problem. So really, I haven't changed anything. I'm just setting this up. So now I'm going to factor the parentheses, this perfect square trinomial. Now, whenever you factor a perfect square trinomial, remember, you're going to get the same binomial twice. So we're going to get some binomial in here, and it's going to be to the second power because we're going to get the same thing twice. And the binomial is, we know this is a plus plus trinomial, so my binomial is going to be x plus. And then what we do to figure out the distinct number that goes here, it's whatever half of that number is. Half of 14 was 7, so whatever number you get here, that's what you put for your factor. Okay? And then we were going to have a minus 49 is equal to negative 73. So that would be what we call completing the square. So now we've done this method, which we've learned in class, called completing the square, and now I'm going to solve this problem out for my value of x. So I'm going to add 49 to both sides of the equation. So why am I adding 49 to both sides of the equation? The reason is because I want to eliminate these 49s from the left side of the equal sign. When I do that, I get a new equation. My new equation is parentheses x plus 7 to the second power, and that's now going to be equal to, those 49s are gone, they eliminated, it's going to be equal to negative 73 plus 49, which is negative 24. Now, my next step is I need to get rid of that power of 2. So how do I get rid of a power of 2? Easy. I do the opposite math operation. The opposite math operation of a power of 2 is the square root. So we're going to square root both sides of the equation. Now, what happens over here to the left of the equal sign? That power of 2 cancels out the square root symbol, and you can see when those cancel out, you're left with x plus 7, and you don't need the parentheses any longer. So now we're going to get x plus 7, and that's going to be equal to the square root of negative 24. All right, now I can't find the square root of negative 24. I mean, if I went to my calculator and I said, hey, calculator, what's the square root of negative 24? You could see that your calculator tells you that it's an error. So that means there is no such thing as a square root of negative 24. All right, but there is a square root of negative 24. What we have to do is we have to simplify the square root of negative 24. So we're going to simplify this. So how do we simplify it? So if you recall, you take the square root of negative 24 and you rewrite it as the square root of positive 24 times the square root of negative 1. Now, by definition, what's the square root of negative 1? Well, that's I. And then we're going to make a factor tree out of 24. We're going to simplify the square root of 24. So 24 is 8 times 3. 8 is 2 times 2 times 2. So the square root of 24, if you notice, becomes, and I'll write it up here, it becomes 2 times 2 times 2 times 3. And to simplify, you need an identical pair of numbers. And you can see I have an identical pair of 2s, so I can simplify the square root of 24. Those 2's go to the outside. And so this simplifies into 2, and then the square root of 2 times 3, which is 6. Excuse the announcements for a second. So I get 2 square root of 6 times I. And the way that I'm going to write that is I'm going to move this I next to the 2. So I'm going to get plus or minus 2I square root of 6. Okay, so I'm going to take this problem. I'm just going to write it over here because I'm running out of room on the side of my paper here. So right now I have the equation x plus 7 is equal to plus or minus 2I square root of 6. How did I get 2I square root of 6? Well, I simplified out the square root of negative 24. And why is it plus or minus? The reason is because whenever we find the square root of anything, whenever we simplify, it always has to be plus or minus. Now my next step of the equation is to subtract 7. I'm solving for x. So I'm going to subtract 7 from both sides of the equation. That would cancel out the 7's, and then we would get x is equal to plus or minus 2I square root of 6 minus 7. And that's the best that you can do for this answer. You cannot subtract 7 from the square root of 6. You cannot subtract 7 from 2I. So that's the best the answer we can get. That would be your simplified answer for x for number 8. Okay, turning it over. Number 9. Now in number 9, 11, 13, 15, and 17, we are simplifying each one of these problems. So number 9, you can see we're taking the quantity 2 plus 5i, we're adding it to the quantity 6 minus 7i. So whenever you add quantities together, parentheses, you want to get rid of the parentheses first and foremost. So I'm going to put a 1 in front of each one of the parentheses, and then I'm going to distribute the 1 to just simply rewrite the problem without parentheses. So what's 1 times 2? 2. What's 1 times positive 5i? Positive 5i. Now I'm going to go over here. What's positive 1 times 6? Positive 6. What's positive 1 times negative 7i? That's negative 7i. So you always want to rewrite the problem without parentheses if you're doing an addition problem. Now we're going to add, or we're going to subtract like terms. So the 2 is like with the plus 6. 2 plus 6 gives me positive 8. I'm just going to write 8. The positive 5i is alike with the minus 7i. So what is positive 5i minus 7i? That is minus 2i. So that's your simplified answer to number 9, or your simplified expression of number 9. It simplifies down into 8 minus 2i. Don't try to subtract these. You cannot say this equals 6i. A 2i is not like with the 8, so we can't subtract. Okay, number 11, we're taking negative 3i and we're multiplying it by 12i. So remember, when you multiply the coefficients together. So negative 3 times 12, that's negative 36. And then you multiply the i's together. I to the 1 power times I to the 1 power is I to the 2nd power. So when you multiply these two together, you get negative 36i to the 2nd power. Okay, now we're not done simplifying because remember, I squared by definition always becomes negative 1. So anytime you see an I squared in the problem, please replace it with negative 1. All right, why do you do that? Well, that's because that's what the Greek mathematicians said to do. All right, so negative 36 times negative 1 would make number 11 equal to 36. Okay, so what is negative 3i times positive 12i? It's 36. All right, number 13, we're multiplying again, but we're multiplying 3 items together. So we're going to take the coefficients, the 7, the 2, and the 5. We're going to multiply those. 7 times 2 times 5, that is 70. And then we're going to take the i's, and we're going to multiply those together. So I to the 1 times I to the 1, that's I to the 2, times I to the 1, that's I to the 3. And that is my answer. So number 13 would be simplified to 70I to the third. How come you don't change I to the third to anything? Well, remember, I to the third has no special value, like I to the second has a special value of -1. So if you get an answer with an I to the third in it, you just leave it. So number 13 simplifies to that. Number 15, we have 2I.